Hi all, this is the second part of set. So in the previous lecture we have seen how to create a set, how to remove elements from a set, how to add elements, how to update a set, how to clear a set. So in this lecture we will see different set operations and also we will see the different built-in functions available and also we will see rows and sets. So these four set operations can be done in Python also. So we know this set operations union, intersection, difference, and symmetric difference. We have already seen in mathematics. The same operations can be done used in Python also. So we will see this set operations with some examples. Okay. So I am creating two sets. A equal to 2, 1, 5, 6, 3. And B equal to set. I'll give some common element here, 5 and 6, let it be common. And I am adding some other elements, 8, 9, and 7. So these are the elements of this set. Now, if you want to perform union operation, so you can use this operator to perform this A line, this line B will give the union operation. You will get the union of A union B. So A union B can be got from this. It is above that slash symbol. You can use this symbol for getting this union operation, or you can use the method also. There is a union method. A union of B can be, sorry, B, capital B. A union B, you will get the union of these two sets. Or you can give B union of A. So this will also result in the same thing. So you can perform union operation using either using this symbol or using union method. Okay. Then second operation is intersection operation. So in order to perform intersection operation, you can use this ampersand symbol, A and B. You will get the intersection of these two elements. 5 and 6 are common in both these tests. So intersection is 5, 6. Or you can use the method also. Intersection method is available. A intersection of B. It will result in B 5 comma 6, or you can give B dot intersection of A. So it will also result in the same element. Okay, in this way you can perform intersection operation. So this is union. After that we have intersection operation. Then we have difference operator. Difference. A minus B is there. So we'll see A and B once more. So these are A and B. Now if you want to find the difference, A minus B can be done. So A minus B will be 1, 2, 3, 5, 6 minus 5, 6, 7, 8, 9. So A difference B, it will be 1, 2, 3. Similarly, B difference A can also be done. So it will be 8, 9, 7. Or you can use the difference method also. Difference A minus B can be written as A difference. So you'll get this result. So B difference A can be written as B difference of A. So using method also you can find the difference. A minus B or A difference B or A B difference A. So using this difference. Then we have another operation known as symmetric difference. Symmetric difference is there. So symmetric difference can be used can be done using this hat symbol. A hat B will give the symmetric difference. So symmetric difference means those intersection elements will be removed. So 5 and 6 are the intersection elements. Except those two elements, all the other elements will be there in A symmetric difference of B. A symmetric difference of B. Okay. And also you can use the method also. There is a symmetric method, symmetric difference method, symmetric underscore difference of B. So you'll get the symmetric difference, and also you can get the B symmetric difference. It will result in the same result. So symmetric difference method can also be used to find the symmetric difference between these two elements. Okay. So these are examples for union and intersection we have already seen. Then next is difference. We have already seen this different, and also about symmetric difference also we have seen this thing. Then these are the other methods that are available in Python. So add we have already seen. Clear we have already seen. Then there is a copy method which will return a copy of the set. Then difference we have seen. Then there's difference update also. Difference update. If you want, you can see the difference update. So what happens is it will do perform this difference update. Difference underscore update of B. So what it does is it does the same difference operation. It will perform the A minus B operation, and here the result won't be returned. Instead, the result will be stored in A. So we know A minus B is 1, 2, 3. So 1, 2, 3 will A will become 1, 2, 3 instead of it has changed 1, 2, 3. So it will be updating that set also. In the case of A difference B, you will find the difference only. But if you are doing this difference update, the difference will be done and A will be updated. That first data object will also be updated. So that's the difference between A difference and difference update. Okay. Then we have discard, we have seen that intersection we have seen. Then similarly intersection update is there. If we are giving A intersection update to B, then A intersection B will be found out and that result will be updated in A set itself. Then is disjoint is there. It returns true if two sets have null intersection. That is, there are both the sets are disjoint sets, it will return true. Then is subset. It will return true if another set contains this set. Subset, you know, subset operation. Similarly, superset is there. Is superset returns true if this set contains another set. Then we have seen pop. We have seen this remove. Symmetric difference I have seen, and also there is symmetric difference update. So it will update the first set or the data object that is used to call that method will be update. Then union is there, update is there. We have already seen all these things. Then we have in operator. Instead, we have already seen this in operator in tuples and list. Similarly, we have in operator. If we want to check whether one in A, it is possible. So it returns true. If it is not there, it will return false. It will return false. So we can search for an element using this in operator. Then we can iterate through a set. So if we want to iterate, we can use this for loop for element in set of. I'm giving a string here. Hello. So using the constructor, I'm creating a set and I'm just printing the elements. Print of element. Okay. Now, if I check the result, it will be like this. LOHE. There is no particular order. So it will make a set, hello, it will make a character set which contains HE, L, and O. So one L will be removed because it is duplicate. And we are printing those elements. Since there is no particular order, any element can be printed first. So here L, O, H, and E are printed in this order. So it can be of any order. We cannot say that this order will be always like this. Okay. Then there are some built-in functions also. We have already seen this built-in function in case of tuples. The same built-in functions are available for set also. So we have already seen all. It returns true if all the elements of the set are true. It will return true if any of the elements of the set is true, or if the set is empty is also. If the set is empty, it all returns false. Then len function, which is used to find the length. So it will return number of elements in the set. Then max will return the maximum, largest item in the set. Min will return the smallest element. Then we have a sorted, like in tuples, we have a sorted function also. But here the set won't be sorted. instead returns a new sorted list from elements in the set. So we'll take the elements from the set and we'll sort it and we'll get a sorted list here. Okay, if we want, we'll check with an example. Okay, we'll see set B will contain this. I'll give some other element A equal to set 2, 4, 1, 6, 9. Okay, so I've given some elements. So if you are using sorted function, sorted of A will return sorted list. So this is in square brackets. So it is a sorted list. So we cannot sort the elements of the set, but the elements will be sorted and will be returned as a new list. If we check that set, it may be something like this. It may not be in this particular order. It can be of any order. Okay. So sorted then sum returns the sum of all elements in the set. We have already seen in tuple also. The next topic is frozen set. So in this certain cases, we may have to the elements should not be changed at all. So in this case, in those cases, we can use this frozen set. So elements cannot be changed once assigned. It's known as frozen set. So if we want to have that, we will see that example. So if we want to have a frozen set, then what you have to do is you have to use the keyword frozen set 23, 12, 11. So this will be a frozen set. So this will be a frozen set. So frozen, if you are using this frozen set, then it will be like this. There will be a parenthesis also. So this is a frozen set. This is known as frozen set. So now B has become a frozen set. The elements cannot be changed at all. Okay, this is known as this is used when we use dictionaries and all. When we want to index dictionaries, we have to use this kind of frozen set. Okay. Then these are the references. Thank you.